I'm building my own wind turbine out of a hoverboard motor. Actually, I want to use both motors placed together, or maybe even three, but that is for later. Because today I want to talk about a crucial component for any wind turbine, and that is the triple phase full bridge rectifier. In this case, it's a very powerful one, as you can see with its own dissipators. So in this video you can get this PCB for free and also check all the components that we need to assemble it, and you will also learn why we use triple phase and not just normal phase, why we use brushless motors and how to rectify the signal. So all that in this video. So guys, if you are also making a homemade efficient wind turbine and you want to rectify the signal, check this project out and learn what is a triple phase signal and how to rectify that. So let's get started. What's up my friends, welcome back. This is the PCB for the triple phase full bridge rectifier, and this is meant to work up to 1500 watts, but that we'll have to test later. Anyway, I want to show you how to assemble this PCB, but first, why do we need a triple phase rectifier with a wind turbine? By the way guys, I'm sharing the files for this PCB for free below the description, so go and download the Gerbers and go to PCBWay.com and order the PCBs, and you'll see that you'll get that together with the part component list and also a guide on how to assemble it and then use it with your wind turbine. So once again, download for free the Gerber files and order it at PCBWay. Okay guys, so in a moment we'll assemble the PCB, but the question was, why do we need a triple phase rectifier with a wind generator? Remember, this is the wind generator that I'm building out of a hoverboard motor. Actually, it will be two. I want to add two of these, but this is just a prototype. What I've done, I've cut some metal bars to size, then I've measured the angles, divided for 6 because I want to use 6 propellers, made the holes, add some screws from the inside, and then add the nuts on the outside, cut them to size, and also made some holes. I'm also planning to make the propellers out of PVC pipes because they are very easy to just heat it up and give the shape that you want, and then add some propellers and test it in the wind. But today we are making the rectifier, which is very important. So, why do we need triple phase? Well, the truth is that we don't need a triple phase generator. Any motor, electrical motor, could be a generator, even one like this, which is a brushed DC motor. As you can see, if I spin it, the LED turns on. That means that I'm generating power. So why don't we use brushed DC motors? Well, we do use, but you see, a brushed DC motor is not that efficient. First of all, it has brushes. And that means that the more you use it, the brushes will wear off. So maybe in 1 year of spinning and spinning, you will have to change those. And not just that, but the wear off of the brushes generate a lot of dust and dirt inside of the motor, so you'll have to clean it. That's why usually we don't use brushed motors. We use brushless motors. And not just that because of the brushes, but a triple phase motor like this one is a lot more efficient. And it's more, we have 3 wires output, so with the same thickness of wire, we can get more power without burning the cables. Because now the power is divided into 3 phases, not just 1 phase. Besides of the wear off of the brushes, the more power due to the triple phase output and less strain on the motor and the wires, it also gives less fluctuations because you have triple phase wobbling around, so the ripple is a lot lower with triple phases because the peaks are more close to each other. On the other side, even if you have an AC motor of only 1 phase, it will generate bigger peaks and you want steady voltage at the output. So that's also a perk of the triple phase motors. Okay, the oscilloscope is connected. So as you can see, we have a sinusoidal wave, which the faster I spin, the faster will be the frequency. So this is just 1 phase. Now we have to see the triple phase in order to know how to rectify. Now all 3 phases are connected with different colors, so let's just spin it. There we have the signals, but in order to analyze them, we have to make a pause. So for that, we make a single, spin it. Actually, let's just zoom out, make another spin. Okay, so there we have the signals. Okay, so let's just understand triple phase. As you can see, the signals look kind of the same. But if you look closer, this one starts here and ends here, on this point. But the other one starts just a little bit back and then ends a little bit back as well, and the other one even more back, and it will end here. That means that we have a phase difference in between, and that phase difference is of 120 degrees, and that's obvious because 1 full rotation is 360 degrees, divided by 3 phases is 120. That's why we have a 1 difference of phase between each of the phases. So now we have to rectify each of the phases, usually using diodes, and that's what we'll see now. I bet that if you're new to electronics or don't know anything about generators, you are wondering why we need to rectify a signal and what is rectifying anyway. Well, rectifying is passing from AC to DC, and the inversion will be passing from DC to AC will be the inverter. So we need to rectify the signal because the generator gives AC and we usually need DC because usually all the solar panels and the wind generators are used to give power to your home, and usually they charge a battery first. And that battery is DC, usually 12 volts, 24 volts, depends on the battery. So we need to get DC. With the solars we already get DC, but with the wind generator we usually get AC. So we need to pass from AC to DC in order to use that with an MPPT charger and charge the batteries. That's why we need to rectify the signal. Okay, so how do we rectify an AC signal? Well, we use diodes. Any diode could do that, but depends on the circuit you get more efficiency or less efficiency, and not just that, but depending on the used component, it will withstand more power or less power. If you use a very small low voltage diode, it will burn out with thousands of watts. So we have to select our components to withstand more power. Remember that I've already made this circuit on a prototyping PCB, but now the PCB for today's project is a lot more professional. So we use diodes. How to rectify the signal? Well, a diode is like an electricity valve. It only allows the flow of current in one direction. And that's very important because for AC signal, as you can see there, each time the signal goes upwards, that means that the electrons are flowing in one direction. And when the signal goes downwards, the electrons are getting back in the opposite direction. So if this is like a valve, all the electrons that are passing in that direction, when the signal is getting downwards, so the electrons will flow in the opposite direction, it will act like a valve. So all the electrons that pass in this side won't be able to get on the other side. So we only get like the positive side of the wave. But that's not enough. Let's just see that on the oscilloscope. Okay, so once again we are at the oscilloscope, and now we are analyzing only one phase, but in the end we'll do the same for all the triple phases. And as you can see, we have the signal connected to the oscilloscope, which is this one here, but I also added a diode at the output, which will be this other signal. So now we can see the normal signal and the rectified one. And by the way, the flow of current of a diode is shown by this bar here. We have like a stripe, usually it's a white stripe here, and that indicates the direction that it will flow. In this case is that one. So let's just give it a spin and see the difference between the rectified signal and the normal signal. There you have it. So let's just make a pause so I don't have to say here. Single. And there you have our signals. As you can see, the input signal, the normal one, is the same as before, a sinusoidal wave, but now the rectified one, as you can see, all the parts that are negative are not showed here. So we get the positive peaks, but the negative peaks, which are going downwards, disappear. So we get only positive voltage. Now this, if you add a capacitor at the output, it will give steady DC. But this is not enough. And can you tell why? Well, because this is still power and we are losing that power. We only get the positive peaks. We don't get the negative peaks, and that is lost power. Actually, it's half of the power which is lost. So we have to get the positive peaks and also the negative peaks. This is called a half-bridge rectifier with only one diode. But if you add more diodes, you can get a full-bridge rectifier, and that will give both peaks, and that's what we'll see now. Okay, so if using just one diode, we can rectify half of the wave, which is a half-bridge rectifier. Using 4 diodes, we can rectify all sides of the waves, both sides. So using 4 diodes in this shape, as you can see here on the screen, we can get a full bridge rectifier. So when the signal is positive, 2 of the diodes will conduct the electricity on the positive side, and when the signal is negative, the other diodes, which as you can see are placed backwards, will conduct the electricity once again. So now we get both sides of the peaks. Let's just mount that circuit on the breadboard and test it and see the difference between a half-bridge rectifier and a full-bridge rectifier. And by the way, instead of using normal diodes like this one, you can also get something like this. As you can see, this is an integrated, already full-bridge rectifier. You even have the signals there for the AC input, the positive and the negative side of the DC output. And these are all the 4 diodes in just one component. And we also have that for triple phase. As you can see, we have this here. We have triple phase input and DC output, and also has a dissipator. This I think is for 100 watts of power or more. No, 1200 volts and 50 amps. That's a lot of power. And we also have an even bigger one, which I think is rated for 2000 watts. I just say here 100 amps and 1600 volts. No, 1600 volts. That's also a lot of power. And as you can see, once again, we have the triple phase input and DC output. So you can get these components, but in my case, I wanted to make my own PCB with dissipators for each of the diode, and we'll see that in just a moment. Let's just see the difference between half a bridge rectifier and the full one. Okay, so I've made a full bridge rectifier with 4 diodes. I've soldered them together. So we have with yellow the input, and now the output with green from the full bridge rectifier. Let's just see the signal. As you can see, we have double of waves on the bottom side. Let's just make a pause to watch it better. Okay, maybe it's too high. Okay, there you have it. Let's just make a zoom and analyze the signal. Okay, so first of all, the input signal is a little bit fuzzy because we don't have the same reference. If we use the same reference for both sides, it will make a short circuit. Anyway, the signal should go here, should be the bottom peak. But as you can see, the rectified signal, now instead of having a positive peak and then a flat zero without output, now we have a positive peak and yet another positive peak. So when the signal is positive, we have a positive peak on the output, and when the signal is negative, we still have a positive peak at the output. So now we get all the power at the output. All this here is positive. As you can see, the ground is here, so all the signal is above zero. So now what we'll have to do to rectify this is to now add this capacitor at the output, which will charge up, and instead of peaks, we get like a steady line. And that's what we will do next. So now with the full bridge rectifier, we get all the signal. We have to add 4 of these diodes for each of the phases. Actually, for a triple phase, we use 6 diodes instead of 4, and you will see that in just a moment. Okay, so now we have rectified the signal. Well, not quite, because we don't have like an AC output, but we still have a ripple. And we need steady DC to charge the batteries. That's why at the output we add a capacitor. A capacitor is like a storage, so on each peak it will charge up, and if the output power from the generator is bigger than the power that we use, it doesn't have time to discharge, so it will stay charged. But the higher is the output load that we will add, the bigger will be the ripple, because it will charge and rapidly discharge. So we need to use maybe a bigger capacitor. If you remember for the prototype, I've used 6 diodes for the triple phase bridge and a big capacitor. So just by adding at the output a capacitor, we will get, instead of ripple, a steady voltage, and then the signal will be rectified. Okay guys, so finally we know the theory, so now we can assemble the triple phase full bridge rectifier. The only thing is that for one phase rectifier we have 4 diodes, and for triple phase we have 6 diodes. We don't need 3 times 4, so 12 diodes. With only 6 we can do that because we use pairs of 2 diodes, so the first pair with the third pair for the first phase, the first pair with the second pair for the second phase, and the second pair with the last pair for the third phase. So just using pairs of 2 diodes, we can rectify all the 3 phases. So now that we have this circuit, you can download the circuit of this entire PCB from below if you also want to assemble it. Also the design and the Gerber file, so you can order it at PCBWay, and also a list of the components that I will use. So let's just check the components that I've selected, the diodes and the capacitors, assemble it, and then connect it to my generator, which I think in the next video I'll have the propellers and mount it on top of my house and see how much power I could get from this hoverboard motor, and also how much power this will withstand without external cooling. And not just that, I want to use 2 of these motors, or maybe even 3. I'll buy some more hoverboards because now you can get them for like $20 from a second-hand store, and maybe place 3 of them in parallel and with a middle rod, and then connect it to a big propeller, which fortunately I can use here because it will be very ugly because it will be very big, but that's the idea for the future. Test it with a lot more power. So let's just assemble the PCB. So this is what we need for our PCB. Obviously the PCB from PCBWay, get the Gerber and order it. And for just $5 you can get 10 PCBs. I've selected the red color. You can select any other color that you want. But then we need some components. For example, 6 diodes. As you can see, I have a different format with a heating pad here, with a heat dissipator pad on the back. And it's very important to also buy 6 heat dissipators. So the first thing that we'll do is to add the diodes to the dissipators and then add them to the PCB. You also need a triple phase connector like this one. This will be the input. and one phase connector like this one for the output. I've also bought a battery, a LiPo battery connector that will go here, because maybe you want to connect this directly to a battery or a charger, which already has this type of connector. Is very common. And then we need 3 capacitors. In my case, I bought this one, 100 volts and 1000 microfarads. We'll have to make some tests if this is enough. If not, I'll have to change the values or even get bigger ones, not just for the voltage, but also the capacitance. And the extra component is an LED, a small resistor, which will just turn on when this is powered on, so you should know that it's generating power. And a small fuse. Now the fuse that I have is for only 300 watts. It will go here, but since you have the pad, you can add a different connector and add a bigger fuse. But for now I don't have the fuse because I've just ordered a bigger one. Until I get it, I'll use just this one for the test. So let's assemble it. First thing I will do is to get the diodes and the dissipators and the given screws and just add them like this. It's also better if you add some heat transfer pad in between. So once I have all the diodes connected like this, then we solder them to the PCB. Okay, so we have the dissipators on the diodes, and now we can solder everything, and there is no order. I'll start with the diodes, the capacitors, which are the big components, and then the connectors. And I'll just do that. And that's it. That easy to assemble this rectifier. As you can see, the diode has 2 pins, but also the dissipator has pins, but the PCB is prepared for that. So just add it here. Okay, I have the diodes. Now I add the capacitors. The polarity is marked by the white stripe, so like this. Okay, now that we have the capacitors, we add the rest of these small components and we are done. Okay, so we have finally completed the PCB. So now let's connect the triple phase from the generator here and check the output. Let's check it out. Okay, so now I have my multimeter connected to the output, but also the scope, because I want to see that indeed it's just a line, it's not AC anymore. So let's just connect the motor to the triple phase input, and I'll just spin it with my drill and see first the maximum voltage that we can get. 62 volts, that's a lot. And as you can see, it is a steady line. Now it's dropping because the capacitors are charged. Actually could touch with the resistor and just discharge the output. I just touch here, see if I can. There you have it, output discharged. And all we have to do now is connect it to a real propeller and see the maximum power connected to an MPPT charger. Just wanted to test how much power we can get from the rectifier with this MPPT solar charger, but you see this is a 24 or 48 system. I only have this battery of 12 volts. Not just that, I have more batteries, so it's not recommended to place in series a lead acid battery with a LiPo battery, but anyway, just for the test, this is another 12 volts battery, so they give 24 volts, as you can see here. We can see the voltage 24, or I think it's 96%, so the 99%. The battery is so charged up that the only power that we'll get up out of this is just 1% of power, maybe 2 or 5 watts. And I can test it. I need a discharge battery, and right now I can do the test without the proper setup. So I will leave that for the next video when I will finally have my propeller and make a proper test. So guys, there you have it. Now you know why we use a triple phase, how to rectify each signal, and how to fully rectify the entire wave and get all the power out of that triple phase signal, and how to make this powerful triple phase full bridge rectifier. So now we are ready for our wind turbine. The project is ongoing. I still have to make the propellers and the support and add it on top of my house. And not just that, remember that I have a washing machine motor, a ceiling fan motor, I have a DC motor made for electric cars, and also the car alternator. All those motors could be used as a propeller generator, a wind turbine generator, so I'll test all that in future videos, because now we have like a small series. We talk about the car alternator, how to pass it from brushed to brushless generator using magnets, about the free energy and the crazy of free energy that does not exist. And now we have our rectifier for triple phase. We can connect it to our hover motor, and I will try to buy some more hover motors and make maybe 3 or 4 connected in parallel and get a lot of power out of them. So stay tuned for that. And remember, download my Gerber files, make the PCB and test it out. Keep up, guys. By the way, guys, this is for all those haters that are writing in the comments. I have a bunch of questions from my previous videos because now this is like a small video series where we have made the car alternator, the hoverboard teardown, and the free energy videos. And now I'm making the wind turbine in a few parts. I'll also make some 3D printed wind turbines in the future. So this video series about free energy, about generators, solar panels, and so on is getting bigger. So I have a bunch of questions that I have to answer to all those haters which are not believing the power or not believing in the circuit. Anyway, if you have any question about the circuit, about this kind of project, leave it in the comment section below, and in the future video I'll try to answer some of those, and also directly in the comment section I'll try to answer those to all of you guys. So yeah, use the comment section below if you have any question. Now yeah, keep up, you guys. So guys, here I am in my workshop, another video that ended. I hope that you like it, and the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel, so thank you very much once again.